Hello and welcome back from spring break. We are now in week 10. We left it was week 8. Week 9 was spring break, and here we are in week 10. And I need to tell you right off that taking a 7-day cruise is not a restful vacation. That is a lot of energy you put out for that. So I hope you've had a more restful. I feel like sleeping all the time. But here we are in the last 6 weeks of the semester. Kind of characterize this as sort of like the back turn on the racetrack. We're not in the home stretch. Still plenty of time to get stuff done. But we're in that sort of, if you're like me, you're coming off of spring break. It's kind of like, wow, I've been working hard all this semester. There's still a bit to go. It's kind of the motivation moment, to kick up, put some extra energy in there, eat your Wheaties, get rest, go out in the sunshine. It's starting to get nice out, and use that energy to get around that turn and go into the home stretch. And here we are diving into our first test related to significance. 2 chapters. One specifically looks at z-scores, and the other one contemplates the distinction between z-scores and t-scores, and has you doing the one sample t-test. So the principal difference here is z-scores are is the distribution of scores when we know all the information about the population. Mostly they're called, we see this used in standardized testing like SATs and the main assessment and all that stuff. We gather the data from the population. We know the mean of any aspect of that test. We know the standard deviation. So then we can look at a sample and we can compare it to the population, and we can know exactly where we fit in to that. Now you've learned about standard deviation, and what z-scores, all they are is you take any test, no matter what the actual raw scores are on there, you take that test and you convert it into units of standard deviation. So a z-score of 1 plus 1 is 1 standard deviation above the mean. Regardless of what the original scores were, that score of a z-score, when you convert your raw score to a standard score, you convert it from, it could be a 20. And if that's what it is, then that's the 1 standard deviation above the mean. -1 z-score, 1 standard deviation below the mean. So then I can look at a sample, and if I have all that data, such as from a standardized test, and I can say, well, this is what my sample did. Where did my sample do in regard to everybody else that's taken this test? And what's their mean? And let's say it's plus 1.6. Then their mean is 1.6 standard deviations above the mean of the population. These kinds of things are beautiful tools to have. Standardized tests are very difficult to create because you have to gather so much data that your data is actually representative of the population. So, pretty hard to do that, but it's great when we have z-scores to go on. This is why standardized testing is used so often. It's a very useful tool. For this, there's a discussion and a quiz. The discussion has you go in, and it gives some information, finding an article that uses z-scores. That means they are using information of which they know the mean and standard deviation of the population. We can use census data for that. We can use population data if we're limiting our population. Let's just say if we're just looking at the population of KVCC students, if I determine that that's my population, I can get z-scores out of that. It also includes all of those research projects that have used standardized developed testing as part of their variables. So you're looking that up and reporting, how did that article use the z-scores, and what are they referencing? What set of data are they saying they know the population mean and standard deviation? Because that's what you have to have. The quiz has you look at a individual sample height and weight and compare it to the average height and weight, and I give you the average the standardized score, population in the United States, the standard deviation and the mean, and you put those into the formula and then discuss where does that weight measure in terms of units of standard deviation, z-scores. So I hope I explained that pretty well. Now, oftentimes we might know the mean of something that's happening in the population, but we don't have enough data to understand the standard deviation. So we're not at a loss. We can take a sample and we can measure the mean and standard deviation of that sample, and we can use a formula very similar to the z-score, except we're estimating the population standard deviation by using the sample standard deviation. So it's essentially the same formula, but we're using the standard deviation of the sample. Now, the key to this is the larger the sample, the closer the variability, standard deviation, of the sample is going to represent the population. So we start to see this relationship between the validity of the test, in this case a single sample t-test, where we're estimating the standard deviation of the population. The validity of that test is directly proportional to the sample size, because the bigger the sample gets, the closer it gets to representing the whole population. So if I'm looking at KVCC students, we have 800 or so full-time students or whatever. So let's say I have a sample of 10. That's not a big part of the whole population of 800. But if I did a study and there was 400 people in that study, those 400, the diversity within that 400 would be really close, probably pretty close to the whole population. What if I had 780? Then it would be almost identical to the population. So you start to see the test being influenced by the sample size. You are going to be conducting a little study using data from the course book to compute your first t-score, which is a single sample t-score, a very common test used when, let's say, I want to assess the validity of one of my assessments. That's using the word assess too often, but let's say I want to determine whether or not my research paper project in my Introduction to Psychology class is, doing what it's supposed to do. I could actually do a t-test on different classes, getting their means and seeing how they do, estimating the variability on the population by using the standard deviation of my sample, and determine whether or not they're scoring in the middle or very high or very low, related to a figurative population of people that have done that particular assignment. So we have that ability to do that. In Chapter 10, there's only an assignment, and that's to compute the single sample t-test. I'm asking you about subliminal perception. They give you the data in percentages. So when you're using percentages, you have the option to put the value in there just as a non-decimal. It could be like 50% is 50, or what it actually means is 0.50. The number doesn't matter. You can do 50 or 0.50. Just be mindful of where your decimal point ends up. Okay, so, and keep in mind that we know the population mean in this particular study because we're looking at basically a coin flip. If there is no such thing as subliminal perception, then everybody has a 50% chance of guessing. So 50% is the predicted sample mean, predicted population mean. If our group of people has a significantly higher or maybe even lower average than 50%, that would be indicative of something's going on like subliminal perception, that is making them get an unusually high number of percentage of correct answers or predicting. So the population mean is 50 or 0.5, whichever modality you use there. So keep that in mind when you're doing the calculation, that the likelihood is 50%. You kind of have to like think about that and do some critical thinking. Well, what is the likely outcome kind of thing? And there's studies where we kind of like figure, well, let's say I'm doing a study on multiple choice tests and each question has 4 answers, then there's a 25% chance someone will guess it right. So my estimated population score on any standardized test is 25. That they would get 1/4 of them right just by guessing. So that becomes my population mean. May not have anything to do with how the population would actually score on that test. It would be my estimate if I was measuring nothing but chance. Good knowledge to have as we reach what from here we're going to be going into additional t-tests where we're no longer comparing to standards, but we're comparing different groups to each other just to see if they're different from each other. We're going to be leaving the land of comparing to populations and moving into the land of comparing groups, which is the vast majority of research that's done in psychology. So z-tests, when we know the population, standard deviation, and mean, and t-tests, when we can figure out, t-tests single sample, when we can figure out the potential mean, but we don't know the standard deviation of the population, we use the standard deviation of the sample to estimate the standard deviation of the population. That's enough of me talking about that. Good luck with this particular. I said there's already people in there, already people talking in the discussions and whatnot as I enter into this week a little bit late. Enjoy this stuff. It's just going to get better when we get into t-tests. Send me any questions. Be well, and I will see you next time.